Okay, it's 8 p.m., so let's start. Okay, hope everyone's revision for tomorrow's paper has been going well. Right, thank you for taking the time today to attend this online Zoom webinar with me as part of Overmark's O-level final revision series. Okay, so I'll be covering the chemistry segment. Okay, so just a quick introduction of myself. So I'm a new chemistry tutor at Overmark. My name is Teacher Zhi Hao, and I teach chemistry from Sec 3 all the way to JC 2 levels. So essentially, O level and IP and H2 chemistry. Okay, for my teaching experience, I was a teaching assistant at NUS Chemistry. So I taught the undergraduate students in their tutorial classes as well as their hands-on lab sessions where I ensure their safety in the lab and as well as to help them complete their experiments. Okay, I also was a relief teacher at a Pioneer Junior College. So now it's Jurong Pioneer Junior College after the merger. And I also taught IB chemistry at a tuition center called Math Vision. Okay. In recognition of my teaching contributions in NUS, I'm very thankful to be awarded these 5 teaching awards. 3 awards from NUS Department of Chemistry and 2 awards from NUS Faculty of Science. Right, and the 2 icons you see below are my socials, so my Instagram as well as my Telegram. So if you have any questions, please feel free to connect with me via these platforms over there. Okay, so aside of chemistry, some fun facts of myself. So this year, I actually participated in the Super 24 event. So for the dancers, this is a annual dance competition held in Singapore, where each team has 24 dancers with only 90 seconds to perform and show the judges our routine. Right, so for those who have watched the event, we are actually the final team in the open qualifiers lineup on Saturday. And no points in guessing which one is me. I'm right here. Okay, and our video, our performance run is actually uploaded on YouTube over here. Right, so for those who are interested, you can take a look. Okay, for those who are not familiar with Overmark or it's only the first time that they see us or get to know us, we are actually a tuition company offering chemistry from secondary all the way to JC levels. However, we are also branching out into the primary market. So now we actually offer upper primary tuition. So from P4 to P6, right? So we cover English, math, and science. We have 7 branches across Singapore to suit your convenience depending on where you live across the island. And we are also the most popular tuition brands online, as you can see the numbers on our different social media platforms, right? We actually have a very high following. So 10.5K, 7.2K is actually, these are not small numbers, right? So you can see the degree of trust and the amount of trust that people have in the kind of service that we provide. And why is this so? Because we have a very solid track record of 70% of our students achieving distinctions in exams. And many of our students go on to pursue their dream courses in top universities. And this all thanks to the hard work from our students as well as the tutors, our highly qualified tutors with a wealth of teaching experience, who provide a very motivating and vibrant learning environment for our students. Okay, so the agenda for today, right? In order to help you achieve your A1 tomorrow, we'll be going through the 2024 O-level chemistry paper 2. Um, I will not only go through the answers, so don't expect me to just read through the answers, but expect explanations of the concepts behind the answers as well. Because if you are here for the answers, then you might as well just open the TYS answer key, right? So I'm here to value add your experience by providing the necessary thought processes to understand the answers as well. And I will go through the more demanding questions first. And if time permits, I'll go through the remaining questions. But nevertheless, the final answer key of the entire paper will be uploaded. Or you can also reach out to me on my Instagram or Telegram as I've shown you in the earlier slide. Okay, so let me switch over my iPad to the answer. So I'll start with question 3 first. So if you can help me, please go through question 3. Okay, so question 3 is on the reactivity series, right? The metals reactivity. Now, before we dive into the question, what's the essential concept of metal reactivity? So the essential concept or the principle is that the more reactive metal can displace the less reactive metal from its cation. So we can see that zinc over here is more reactive than copper. So it can displace copper out of copper 2 plus. So essentially, you can think of the metal atom, the metal species being kicked out of the aqueous solution, if that helps you to understand. Okay, so the more reactive metal can displace the less reactive metal out of its cation. But can things happen the other way around? No, because the less reactive metal will not be able to displace the more reactive metal. So in this case, copper, right, being the less reactive metal, it will not be able to displace zinc out of Zn2 plus. Okay, so this is the essential concepts. Then how do I know which metal is more reactive or less reactive? Then you have to go back to the reactivity series. Now, for the reactivity series, different schools teach different ways to memorize the please stop calling me a zebra, stop calling me whatever, whichever mnemonic that helps you to memorize the reactivity series. So the more reactive metals at the top of the series will tend to form cations more readily, as opposed to the metals that are below in the series. They prefer to stay in their metal zero oxidation state. They don't like to form cations. So the more reactive metals will like to form cations, whereas the less reactive metals, they don't like to form cations. They like to stay in a metal state. And this is why we can see that zinc versus copper, zinc being more reactive, it prefers to be in the cation. So this is the reason why a more reactive metal can displace a less reactive metal out of its cation. Now, when you have a reaction taking place, what will you observe? You observe a color change, right? But if there's no displacement occur, then there will be no reaction. So if you take a look at this table over here, some blanks have already been filled for you already. So when you see no reaction, what does this mean? This means that there is no displacement that is taking place. Why is this so? Let's take a look at one example. So we have silver versus lead nitrate. So if we put silver into lead nitrate, what's going to happen? Then we have to ask ourselves, silver and lead, which one is higher in the reactivity series? We can see that lead is the one that's higher in the series, is more reactive, and silver is the one that's less reactive. Now, when we put silver Ag into Pb2 plus, can silver displace lead? The answer is no, because silver being less reactive cannot displace the more reactive metal out of its cation. So this is one example. What about the other example? So we have magnesium, right? So magnesium, if I put inside silver nitrate, Ag plus, so magnesium is more reactive than silver, so it can displace silver out of its salt. So when you put the magnesium into the silver plus aqueous solution, you'll see a gray coating, which is the silver solids being formed. Why? Because the silver is being displaced out of its salt. So clear on these two examples. I'm not going to go through every single example, but I'm just going to use these two examples on one scenario where displacement can take place and the other scenario where displacement cannot take place. Okay, now these are the blanks that were in the question, and these are the answers. Now, why is this the answer? So lead and silver, Pb. Right, so Pb we have discussed already is more reactive than silver, so it can displace silver out of its cation. So the gray solid is your silver. Okay, for lead versus Zn2 plus. So lead is less reactive than zinc. So lead cannot displace zinc out of its salt. So that's why there's no reaction. Lead is also less reactive than magnesium, and therefore it cannot displace magnesium out of its salt. Okay, clear on how I arrived these answers? Okay, part B, write the ionic equation for the reaction between zinc, metal, and silver ion. So for ionic equation, you have zinc in the zero oxidation state, displacing silver out of its salt. Now, when you write ionic equations, I want you to pay attention to this. Most students will only focus on ensuring the elements are balanced. Okay, so I have Zn and 2Ag on the left-hand side, Zn and 2Ag on the right-hand side. But when you talk about ion equations, you must also ensure the charges must be balanced. So on the left-hand side, I have a +2 charge. The right-hand side, I also have a +2 charge. Take note that you have to ensure elements and charges are balanced. If they are not balanced, it is not an equation, okay? Part C, which metals in table 3.1 provided sacrificial protection for iron? So what does sacrificial protection mean? What does sacrifice mean? Sacrifice in terms of what? So in this case, is sacrifice in terms of oxidation, sacrifice in terms of reaction, sacrifice in terms of forming the cation. So in order to react in the place of iron, to sacrifice itself for iron, it must be more reactive than iron, isn't it? Otherwise, how is it going to sacrifice itself for iron? Correct or not? So, of all the metals over here, which are the ones that are more reactive than iron? So we can see that of the list of metals here, only magnesium and zinc are more reactive than iron. So therefore, they will be the only candidates to provide the sacrificial protection for iron because they have a greater tendency to oxidize in place of iron. Okay, the next one, silver carbonate, lead carbonate, and magnesium carbonate have different thermal stabilities. Okay, so put these three carbonates in order of least to most thermally stable. Now, before I go through the answer, which I know you all can really see, I just want to highlight a principle. A more reactive metal forms a more stable compound, which means it's harder to decompose. Why is it so? Because more reactive metals, they form more stronger bonds, and therefore it's harder, you need more energy to break the bonds, so that's why it's harder to decompose. Conversely, less reactive metal forms a less stable compound, and therefore it's easier to decompose. So if we talk about the reactivity series over here, so we can see that magnesium, okay, so magnesium is the most reactive, followed by lead, and then followed by silver. So therefore, magnesium carbonate will be the most stable. Silver carbonate will be least stable. Okay, so more reactive metal, more stable compound, harder to decompose, and vice versa for the less reactive metal. Okay, so here's for question 3. I'll move on to question 4. Okay, question 4. Haber process uses nitrogen and hydrogen. Where are these two gases obtained? They are obtained from fractional distillation of liquefied air for nitrogen because why? Liquefied, we know air contains 70% of nitrogen. Hydrogen can be obtained from the catalytic cracking of crude oil. Okay, or long chain hydrocarbons. So a pretty factual question over here. The next one, the percentage yield of ammonia at different temperatures and pressures is shown below. So before even diving to the question, what can you observe? So this is a good habit to know when you do exam questions. Before even diving into the part A, part B question, ask yourself, with the data given, what information can I get? So I can see that when I decrease the temperature, what happens to the yield? The yield will increase, correct? Likewise, when I increase the pressure, the yield will also increase. Then by logic, you would think, why not I just take 350 degrees and 400 atmospheres as my optimum pressure since it gives me the maximum yield of ammonia. Why not, right? Why choose 450 and 200? Now, there's a caveat now. When you put temperature too low, what's going to happen? If the temperature is lower than 450 degrees Celsius, the rate of the reaction will be too slow. Why is it so? Because we know that temperature is related to the kinetic energy of the particles, right? So with lower kinetic energy, lower frequency of effective collisions, it will affect the rate. So no point having a reaction that's high yield but also that is very slow, right? Economically, it's not very wise as well. What about pressure? Why don't I use 400? Why choose 200? Now, if the pressure is too high, there needs to be very expensive equipment to maintain the high pressure, right? And it can also be quite dangerous if for very high pressures as there's greater risk of explosions. Now, if the pressure is too low, we can already see with the graph, the yield of ammonia will be very low. Okay, now, next part, ammonium sulfate is an ammonium salt that's added to soil as fertilizer to provide nitrogen to aid plant growth. So actually, most fertilizers contain ammonium cation. right? The ammonium cation contains the nitrogen content. Calcium hydroxide can also be added to the soil for different reasons. Explain why ammonium sulfate and calcium hydroxide should not be added to the soil at the same time. Now, let me ask you, what is ammonium sulfate? What is calcium hydroxide? So ammonium sulfate is basically an ammonium salt, correct? It's an ammonium salt. Calcium hydroxide is a base. Now, at this point, I want to highlight a very important concept. Reactions of bases. When I ask students, what are the reactions of the bases? Most students can tell me the first one, base plus acid forms salt and water. This is the most common one. But when I ask what's the other reaction, actually most students will struggle to answer because most students will always remember one, but they will always forget the second reaction of the base. So what is the second reaction of the base? A base can react with ammonium salt to form salt, ammonia gas, as well as water. So what is an ammonium salt? Essentially, ammonium salt contains the ammonium cation and any other anion. So ammonium chloride, ammonium sulfate, ammonium carbonate, they are considered ammonium salts. They will form salt, ammonia gas, and water. So this one turns your damn red litmus paper blue, right? For the test of ammonia gas. Now, the question is asking what's going to happen if you add calcium hydroxide and ammonium salt. So what is calcium hydroxide? We already covered that calcium hydroxide is a base. And what's going to happen if you combine with the ammonium sulfate? It will form ammonia gas. And ammonia gas is a gas. What's going to happen to the gas? It will escape into the air, correct? What's the problem of ammonia escaping into the air? The fertilizer is to provide nitrogen content, correct? What does ammonia contain? Ammonia gas contains nitrogen, right? So if your ammonia gas flies into the air, what's going to happen? You have less nitrogen content to aid your plant growth. Okay, so you're expected to write the equation and then explain that you will react with ammonium sulfate to form ammonia gas, which escapes into the air, loss of nitrogen content for plant growth. Okay, once again, don't be frantic to copy everything down. Focus more on my explanations because the answers will be sent over in Telegram. Okay, next one, redox. Right, so we have a list of anions over here. So what does this nomenclature naming mean? So the bracket is essentially the oxidation state of the element. So you see the Roman numeral 3 means the oxidation state is 3. Oxidation state of what element? Of this note of chlorine. Likewise, for oxidation state of the manganate, right? 7, because this is Roman numeral 7. So this one is plus 7, this is plus 3. Okay? Likewise, this is plus 5, and so on and so forth. Okay. A, which oxyanions form colored compounds? So colored compounds, you can think of transition metals. So of all these elements, which oxyions, right, are formed from elements that are transition metals? Right? Manganese and vanadate, right? You should remember from redox chapter that potassium manganate is an oxidizing agent that turns purple to colorless when it oxidizes a certain species, right? So this is another clue that you can use to answer this question, right? So because this manganate comes from your potassium manganate, right? Potassium manganate by default is purple. So even if you see this question for the first time, you can straight away list MnO4 minus as one of the answer. Okay, so these two oxyanions, because they are formed from transition metals. Okay, next, state the formula of aluminum chlorate. So chlorate has an overall charge of -1, and aluminum has an overall charge of 3 plus. So how many chlorate ions do I need? I need 3 of chlorate ions to balance out the 3 plus. So this will be the formula. Okay, suggest the name of the oxy-ion CrO4 minus. So for oxidation state, the sum of oxidation state is equals to the overall charge of the species. So for chromate, what is the overall charge? Is -2. Right, so that means the sum of 1 chromium and 4 oxygens must be equals to -2. So oxygen is -2, right? So oxygen is always -2 except for peroxides and elemental oxygen. So if 4 times -2 is -8, then what must be chromium? It must be +6. And then +6, the Roman numeral is this. So chromate 6. Okay. Sulfate. has is an oxygen element with a 2 minus charge, right? So which means this 4 is the oxidation state of your sulfur over here, the sulfur oxidation state. Okay. And we have already discussed sum of all oxidation states is equals to overall charge. So here we have sulfur plus 4, oxygen is minus 2. Why? Oxygen is always minus 2 except for peroxides. So example of peroxides will be your hydrogen peroxides or your group 1 metal peroxides. Okay, in these cases, the oxidation state of the peroxides will be minus 1. The other exception will be elemental oxygen because anything in its elemental form is 0. So which means the sum of sulfur and oxygen must be equals to overall charge minus 2. But I don't know how many oxygen atoms do I have yet. So what do? I just put as X first. So this is oxygen, right? And then this is my sulfur. This is my overall charge. So I let the number of oxygen atoms be X. I solve for it. X is equal to 3. I get 3 oxygen atoms. And therefore, this will be the formula of my sulfate. Clear? Okay, next one, dot and cross diagram. Okay, this will be the dot and cross diagram. Ensure that you differentiate between the double bonds and single bonds. Okay, so these are my double bonds and this will be my single bonds. Okay, so common mistake is students tend to forget to draw the bracket and label the charge, and then they minus the marks. Why? Because drawing this diagram is already very mentally draining, right? So many dot and crosses to draw. By the time you draw this, you maybe feel tired. Then you just move on. Then you forget to draw the bracket. So please, please, please don't forget to draw your bracket and the charge for anions or cations. Okay? And also don't forget to draw your legend. Okay, so I will move on to question 7 for now. Then later if I have time, I'll go through the remaining questions. Okay, so because question 7 and 8 and the rest is more demanding, I want to spend more time on the more demanding questions first. Okay, so in this question, we have a passage about crude oil. So I assume that you have already read through the passage and highlight the important points. So I'll jump straight into the question. Okay, name the homologous series to which the carbon compound is produced in the hydro desulfurization process. So which one is the hydro desulfurization process? It will be this one. Okay. And then what is the homologous series of the compound that's being formed? So we have RH, right? So RH, R is CnH2n plus 1. If R is CnH2n plus 1, then RH must be CnH2n plus 2. And what is the general formula of this? What series does this general formula correspond to? It corresponds to the alkane series. So the series must be alkanes. Okay. Which substance is oxidized in the hydro desulfurization process? It will be hydrogen because the oxidation state of H2, anything in the element form is always 0. Okay, and then in H2S, S is minus 2, is plus. This H must be plus 1. How do I know S is minus 2? How do I know that? Sulfur and oxygen, they are from the same group, right? They are from the same group. So same group means what? Similar chemical properties. So I just compare to H2O. H2O versus H2S. If H2O, the O in H2O must be minus 2, then the S must also be minus 2. Right? Same group, similar chemical properties. And therefore, the hydrogen must be plus 1. So hydrogen oxidized from 0 to plus 1. Therefore, it is the one that is oxidized. Okay. Calculate the mass of sulfur dioxide that can remove from 1000 kg of limestone, which is your calcium carbonate, in a flue gas desulfurization process. Now, in the passage, right, it says that it is only 98% pure. Okay, so we can see the purity of the limestone. So this is your limestone, the purity of the limestone is 98%. Right, so you do not just take this 100 and divide by the molecular mass. You have to account for the percentage purity first. Then this will be the true mass of your calcium carbonate. Okay, after that, divide by the MR of the calcium carbonate, you find the number of moles. And based on the mole ratio of the chemical equation, 1 is to 1, So the number of moles of the sulfur dioxide must be the same as calcium carbonate. Then from here, just multiply by the MR of sulfur dioxide, and then you will get the maximum mass of SO2 that can be removed. Okay, you can write this in kilograms or grams, right? Both will be accepted. Okay. Next, write the balance equation for the reaction between nitrogen dioxide and calcium carbonate. So essentially, it's this part of the question here. So they already gave you the products over here. All you need to do is to write the chemical equation and balance the elements. Now, students will ask, so if question don't never request for state symbols, do I write? I would say if you are practicing if you're practicing past year questions or doing your own revision, you may write. But when it comes to exams, if the questions don't ask you to write, then don't write. Why? Because even if you know the state symbols, there might be a chance that under stress or fatigue, you may accidentally write the wrong state symbol. It happens. It really happens. Right? You may think you write equals, but accidentally you wrote guess. Right? So why minus those unnecessary marks? Right? So unless the question specifically asks for state symbols, if it's not requested, then don't have to write. Okay? Now, during catalytic reforming, some of the sulfur compounds bind to the catalyst surface, suggests why this process make it less effective. So which part of the passage here? Right, so it's written here, sulfur compounds bind to the catalyst and make the reactions less effective. Now, catalyst and surface. So I have this catalyst surface over here, right? And then this surface is meant for my reactant molecules to bind, to collide with the catalyst for the reactions to take place. Then what's going to happen if, let's say, I have sulfur compounds, right? These sulfur compounds blocking this surface, occupying this surface. That means will I have more surface area for the reactants or less surface area? I will have less surface area for the reactants to collide with the catalyst. Then what's going to happen to the frequency of effective collisions? It's going to decrease, right? So there'll be a decrease in surface area of contact between the reactant particles and the catalyst, and therefore the catalyst is less able to reduce the activation energy. Overall, you will reduce in the rate of reaction, right? So catalyst, you can always link to rate of reaction. Okay, clear? Now, catalytic reforming of heptane produces two compounds, right, of 98 and 100. So if you calculate C7H16, you notice that its MR is 100. And now the question is telling you that it forms products of molecular mass 100, which is the same as your C7H16 reactant starting material, which suggests that this 100, right, it could correspond to C7H16 as well, which means that these two are isomers. Likely isomers. Same molecular formula, but different structural formula. Then what about the 98? If C7H16 is 100, 98 must be C7H14 because I take away two hydrogens. Right, so can you see, even just by reading the question, I try to analyze and obtain information. Now, in the passage, what kind of products does catalytic reforming produce? It produces branch molecules or cyclic molecules from straight chain molecules. So these are straight chain molecules. What is a straight chain molecule? Straight chain molecule, essentially the carbon 1, 2, 3, 4, 5 is in one straight line. For branch, that means the 1, 2, 3A, the 3 is not in the straight line anymore. Can you see that? Right? The 3 is no longer in the straight line. This is called branch. It's no longer a straight chain. Then cyclic, just by the word cyclic, it's quite self-explanatory. It's like a cycle, right? It forms like a closed ring. So, which means these two products, one must be cyclic and one must be branched. So how do I draw the branch? Essentially, based on the question here, you can see that it takes this CH3 and then just move here. It's like playing Lego block like that. It's like playing puzzle like that. Just take this and shift here, right? And then this H is here. So I just do the same thing. I take this and I just plug 1 meter over here. I copy exactly what the pattern the question give me. Can you all see that? Then the cyclic straightforward, I just take these, puzzle piece, connect together, minus 2H, and form this H2. Right, this is playing puzzle, right? Not really chemistry. This part is really like playing puzzle. Okay, so you can see, this is my cyclic molecule and this is my branched molecule. Okay? Okay. Okay. Moving on to question 8 now, electrolysis. Okay, I don't want to jump into the question first. I just want to take some time to cover the concept. Okay, now you see battery is electrolysis. The first thing you must do, don't jump straight into the electrolytes and everything. Focus on the battery first. Label the positive and negative. If this is positive, this must be negative, and this must be positive, and this must be negative. Okay, so I saw a chat in the group about asking me to repeat the explanation. Okay, so let me just repeat this catalytic reforming again. So based on the question, right, how do I form the products? So from a straight chain molecule, I form a branched molecule. Okay, so how do I form the branch molecule from the straight chain? So essentially, pay attention to my numbering. 1, 2, 3, 4, 5. Here I have 1, 2, 3. Now my 3 is no longer in the straight line. The 3 is bonded to carbon 2 in a branch here. Then this will be my C4 and C5. So essentially, if this is my starting material, right, CH3, CH2, 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 4, CH2, CH2, CH3, right? Just take this, you shift over like a block like that, then you will form this. Okay? Okay, in this case, right, is catalytic reforming is in the combined syllabus. Actually, this is an application question, right? Sometimes, even though the concept might be out, like in this context, this kind of reaction is you didn't specifically learn in the O-level syllabus, but sometimes the analytical skills that you're required to know is part of what you're expected as an O-level student. So in this case, it's testing not just chemistry, but more of the analytical skills. Can you actually recognize the pattern, right? The pattern of the reaction, and then you try to form the products from there. Okay? Can? Okay. Okay, scare me. For a moment, my screen got frozen. Okay, everybody can see my screen. It's not frozen, right? Okay. Okay, for those who didn't manage to ask or clarify every single doubt in this session, don't worry, I'm still available after the session. I'll stay back in the Zoom to answer some of your questions, or you can also reach out to me on Telegram as well. Okay, now jump straight to electrolysis. So what did I say? Don't jump straight into identify the products first. So don't always just rush through, okay, what is being selectively discharged at the anode and cathode. Right, first focus on the battery. So this is my positive and negative, and therefore this must be positive and this must be negative. Okay, then positive anode or cathode. Now, let me give you a very easy to remember panic. But don't panic during your exam. Okay, so panic, positive anode, negative is cathode. So this is an easy way to remember. Another common concept students forget, oh, anode, cathode, which one is oxidation or reduction? Then just remember these two animals, anox and red cat. Anode oxidation, reduction is cathode. Okay, so these two mnemonics should help you remember electrolysis. Now, focus on the positive electrodes, right? The positive electrode, what kind of species does it attract? It attract the anions. Makes sense, right? Because anions are negatively charged. Negatively charged will want to flow to the positive electrode. Then, for negative electrodes, it will attract cations because cations are positively charged. So positively charged species will migrate to the negative electrode, which is the cathode. So once again, positive electrode will attract the cat with the anion. The negative electrode will attract the cation. Then what are my cations and anions? So here, copper 2 sulfate, what do I have? I have copper, I have sulfate. Is that all? No, I have aqueous. So aqueous is H2O, H plus and OH minus. Okay. Now, The positive electrode will attract the N ions. So what are my N ions? Sulfate and hydroxide. Which one is being selectively discharged? It will be the hydroxide. Now, negative cathode, negative electrode will attract the cation ions. What are my cation ions? H plus and Cu2 plus. Which one is being selectively discharged? Cu2 plus. Okay, so these are my half equations for the anode and the cathode. The hydroxide will be selectively discharged at the anode. The copper 2 plus will be discharged at the cathode. Okay. Now we are ready to answer the questions. So number of moles of SO4 2 minus ions increase, decrease, or stay constant. Is SO4 being discharged in either electrode? The answer is no, because on the positive anode, OH minus is the one that is selectively discharged, so this one will remain in solution. Okay? It remain in solution, and therefore it will stay constant. What about total mass of apparatus and solution? Now, take a look at the anode and the cathode. So for cathode, there's no gas being produced. But for the anode, right, the oxygen in your hydroxide, right, will convert into oxygen gas, and this will escape into the air. Oxygen also has mass, okay? It also has mass. So if more and more oxygen escape into the air, what's going to happen to the total mass of the entire setup? It's going to decrease. Okay. What about the pH of the solution? So at the anode, OH is being discharged, right? The OH minus concentration will decrease. What about H plus ions? So at the cathode, Cu2 plus is being discharged preferentially over H plus. H plus will remain in solution. So OH minus discharge, H plus will remain. So over time, which one will be more? The H plus will be more than the OH minus ions, right? So if H plus will be more than the OH minus ions, therefore the pH will decrease. Okay, so pH will decrease. What about the mass of the negative electrode? What's the negative electrodes? Is your cathode, right? The cathode, Cu2 plus will be deposited on the cathode. The size of the cathode will increase, and therefore the mass will also increase. Okay, can? Okay, now next one. The experiment is repeated with concentrated sodium chloride and dilute. So for the electrolysis of dilute sodium chloride, write the ionic equations for each electrode. So for dilute cases, for the dilute case, you have a large amount of your H2O. So with a large amount of H2O, the OH minus and the H plus from the H2O will be selectively discharged at the anode and cathode respectively. So these are your half equations. Okay, explain the results shown in table 8.2. So for dilute, right, the H plus and OH minus will be selectively discharged, right, as shown in this question already. For concentrated, the only change is that OH will be changed to Cl. So Cl minus will be the one discharged at the cathode and respectively. Now, for the mass of electrodes, right, it's constant for both because no solid is being deposited at the cathode and there's no oxidation of the anode. Okay, the total mass of the setup will decrease, right? The total mass of the apparatus and the solution will decrease because in the previous case, what causes the total mass to decrease is because the presence of gas escaping to the air. Then you have to ask yourself, in these two cases, are there gases escaping to the air? Yes, oxygen gas, hydrogen gas, and for the concentrated, it will be hydrogen gas and chlorine gas. So in both concentrated and dilute, in both cases, both will produce gases that can escape into the air, and these gases have masses. So what's going to happen? The mass of the setup will decrease. Okay. For pH, all we need to do is just like the previous case, we have pay attention to what's going to happen to the concentration of OH minus and H plus ions in each case. So for the concentrated NaCl, right? Na and OH is being left behind. So over time, the concentration of OH will outweigh H plus, pH will increase. For the dilute case, right, NaCl and Cl minus left behind, right, because H plus and OH minus is being discharged. So both of them are being discharged at the same rate. So if both are being discharged at the same rate, that means at all times, the concentration of H plus and OH minus will be the same, and neither species will outweigh the other. So therefore, the pH will be constant. Okay, clear? Okay, next one, question 9. Okay, here is about the reactions of acids with calcium hydroxide. So this is your base and this is your acid. So acid plus base form salt and water. Okay, explain. Okay, because how do you know it's the same rate? Okay, because it's the same battery source, right? The same battery source, it provides the same amount of energy to both electrodes, assuming the ideal condition, assuming that neither electrodes are faulty, or assuming that both electrodes are in the same working conditions. So it's more of thinking like, okay, as all factors constant. When we analyze science, right, when we want to analyze a variable, sometimes we need to keep the other variables constant. So in this case, we assume that both electrodes are working and they come from the same battery source, and both the H plus and OH minus ions come from the same water solution. So isn't it reasonable for me to assume that both H plus and OH minus ions will discharge at the same rate? Same battery source, same working conditions for both anode and cathode, and both the H plus and OH minus come from the same water body, right? Okay. Okay, next one, acid. Explain the difference between the pH values of ethanoic acid and hydrochloric acid. Now, before you compare pH values of different acids, one strong, one weak, you need to assume, you need to make a very important assumption that both acids must be the same concentration. Okay, of acids of concentration of 0.1. Okay, so this is the same concentration for all acids, right? Otherwise, if it's different concentration, then you cannot compare based on pH already, because pH depends on concentration of H plus. Okay, so before you compare the pH of different acids, you need to ensure that all of them are the same concentration, right? It's already fixed here. Same concentration is fixed. Then I can safely compare why is this acid higher pH than the other one. Now, the difference between the pH values of ethanoic and hydrochloric. So both are monobasic acids, but one is weak and one is strong. So ethanoic acid, weak acid, it only partially dissociates to form a low concentration of H plus. On the other hand, HCl strong, fully dissociate, higher concentration of H plus. For the acid of the same concentration, HCl will produce higher concentration of H plus, the pH will be lower. Okay, so pH has an inverse relationship with the concentration of H plus ions. More H plus ions, lower pH. Explain the similarities and differences between the volumes of ethanoic acid, HCl, and H2SO4 needed to neutralize the. Yes, you can use dissociate and ionize interchangeably, right? They both mean the same thing. When you ionize in solution to form H plus, or you dissociate in solution to form H plus. So basically, ionize, this word ionize. Ionize means to form ions, right? Dissociate in this context of acid. Acid dissociates to form H plus ions. Ionize is the process of forming ions. So in this specific context, ionize and dissociate both mean you form the H plus ions. Okay, did I answer your question? Okay, for those who type in the chat, I didn't manage to answer, don't worry, I will attend to it after this 1 hour session is done. So for now, I'll just prioritize on the O-level paper first. Thanks for your understanding. Okay, so for the similarities and differences between these acids, so HCl and ethanoic acid, they are both monobasic acids, which means they use the same number of moles H plus. So monobasic means, right, 1 mole of acid produce 1 mole of H plus ions. So if they both use the same number of moles of H plus ions, right, they will use the same volume. They will use the same volume to neutralize 25 cm3 of COH2. But on the other hand, H2SO4 is dibasic. It dissociates to give twice the amount of H plus ions, and therefore only half the volume of H2SO4 is needed. Okay. Next one, write the equation for the reaction between aqueous ethanoic acid and calcium hydroxide. So it's basically just the balance of the equation over here. Make sure you don't make any careless mistakes for these kind of marks, okay? Calculate the concentration of calcium hydroxide used in these experiments. So I can take any acid and in the table over here to react with the calcium hydroxide. So let's say I use HCl. I calculate the number of moles of HCl, right? So take the concentration, which is provided in the question, multiply by the volume, and I get the number of moles. From here, I calculate the mole of calcium hydroxide based on the mole ratio, because the mole ratio is 2:1, right? So I need to divide by 2, okay? After that, the number of moles divided by the volume of the calcium hydroxide. Where do I get the volume? Here, 25 cm3 of calcium hydroxide. Then I'll get the concentration, and this is 2SF as required by the question. Okay. Next one, the ionic equation and enthalpy change for the reaction of 1 mole of hydrogen ions are shown below. Now, here, this minus 57 kilojoule per mole is per mole of what? Pay attention to this equation. What does this equation involve? It involves H plus ions neutralized with OH minus ions and to form H2O. How many moles of H plus ions is present in this chemical equation? 1 only, right? So what does this per mole mean? This per mole means per mole of H plus ions. So this is something that you need to pay attention to when you do your calculation. Okay, so first I calculate the number of moles of H2SO4, right, which is 0.00125 moles. Can I just take 0.125 and multiply by minus 57? The answer is no, because this is per mole of H plus ions, not per mole of H2SO4. Right? Look at this equation, it's per mole of H plus ions. So I need to calculate the mole of H plus ions. So 1 mole of H2SO4 forms 2 mole of H plus. So I will take this number of moles multiplied by 2. This is the true number of moles of H plus ions. And then the enthalpy change, minus 57 kilojoules per mole multiplied by 0.025 mole. So kilojoules per mole multiplied by mole, the mole will cancel out and I'll get kilojoules. Okay? Okay, next one is also a reaction with acid, but now instead of base, it's with metal. So excess acid, what does this mean? This means that this is a limiting reagent. Why do I care about what's the limiting reagent? This one will determine the volume of H2 that's being produced. Okay? So here, time taken to collect the 10 cm3 of gas for this concentration of acid is 25. Okay, part A says that the experiment is repeated with nitric acid, sulfuric acid, and ethanoic acid. The acid is in excess each time, which means on all occasions, magnesium is still the limiting reagent. Okay? And all other conditions remain the same. So it didn't say that the magnesium is changing, right? So all other conditions remain the same, which means the number of moles of magnesium, which is the limiting reagent, must be the same. So I don't need to worry about magnesium being a variable in my comparison. I just need to focus on the acids, right? How does the identity of the acid affect the time taken to collect 10 cm3 of gas? Predict and explain the results for each acid. Nitric acid will be the same as hydrochloric acid because both are strong monobasic acids, fully dissociate or ionize. They will give the same concentration of H plus ions which affect the rate of reaction, right? Because rate is affected by what? These 5 factors. Now we are focusing on Oops, concentration. So concentration is one of the factors affecting the rate. Okay, so the concentration of H plus ions will be the one affecting the rate of reaction. So both produce the same concentration of H plus, therefore the rate is the same. Sulfuric acid, we have already covered in the earlier question, dibasic, twice the amount of concentration of H plus ions. Then how is it going to affect the rate? It will increase the frequency of effective collisions, therefore increase the rate. So if I have higher rate, faster rate, will the time taken still be 25, less than 25, or more than 25? If it's faster, it will be less than 25. Okay, you don't need to specifically state an exact number, right? You just need to state less than 25, okay? Faster rate of reaction because twice the concentration of H plus ions. Now, ethanoic acid, weak monobasic acid partially dissociate, lower concentration of H plus ions. Right, once again, concentration affects the rate. So when I have lower concentration of H plus, I will expect a slower rate of reaction. So 25 seconds, will it be more than 25 or less than 25? If it's slower, it will be more than 25 seconds. Okay? Then the experiment is repeated, but they change the condition. Now the gas can escape. Previously, the gas cannot escape. Now the gas can escape. Right? The flask is weighed as soon as the acid is added, and again when the reaction is finished. And then there's a change in mass of the flask. Now the change in mass is due to what? Right. Let's bring back to the electrolysis question. Right. The electrolysis question, we mentioned that the change in mass is due to gas escaping, right? The same principle can be used in this case because why? In this case, hydrochloric acid reacts with magnesium also forms hydrogen gas, right? It's a gas and it has mass. And if the gas is allowed to escape, the mass of the flask will change. So that means any change in mass of the flask is due to the change in the escape of hydrogen gas. So all I need to do is calculate the mass of hydrogen gas, which is 0.063 grams, if you have done your calculations correctly. And this will be the change in mass of the flask. Okay. Next one, identify all the species which remain in the flask. So what is excess? What is the limiting reagent? HCl is in excess. Limiting reagent is magnesium. So limiting reagent will be used up in the end, right? There will be no limiting reagent remaining. The only reagent that's remaining will be the excess HCl. Okay, so aqueous magnesium chloride, which is your salt, because acid plus metal gives me salt and hydrogen gas, right? So your salt is your magnesium chloride, and then of course excess HCl. The experiments repeated with 0.75 grams of zinc with excess HCl. Again, this is the limiting reagent. Okay, this one will be the one that determines the volume of H2 produced. The change in mass in the end is less than the change in mass when magnesium used. So which means what? If the change in mass is less, does that mean I have more H2 gas produced compared to magnesium or less H2 gas produced compared to magnesium? I will have less H2 gas produced. Why? What determines the volume of H2 gas being produced? Is it HCl or zinc? It will be zinc. Right? Limiting reagent is the one that determines the H2 gas, the volume of H2 gas that is being produced. So which means I have less number of moles of my limiting reagent compared to number of moles of magnesium. Right? And why is it so? Both are 0.75 grams. Then how come the number of moles is less? It must be the atomic mass that's different. The atomic mass of zinc is 65, for magnesium is 24. So at the same mass of 0.5 grams, the number of moles of zinc will definitely be less than magnesium, right? And therefore, having a larger relative atomic mass, for the same mass, there will be less number of moles of zinc being produced, and therefore there will be less hydrogen gas being produced. Okay? Okay, let me see if I can go through just one part. Okay, okay, I think I will go through, yeah, sorry. I'll go through, yeah, this one. Okay. So this is question four, right? Question six. Question six, part E. Okay, so chloride reacts with water, and then the equation is being shown over here. And the equation has provided the state symbols for you already. This silicon chloride is added to the beaker of water, which contains a universal indicator. Describe what you see during the reaction. Now, here you have a insoluble compound, which means it is a solid. And this solid is white in color. So you observe a white solid due to the formation of insoluble silicon dioxide. Now, HCl is also produced, which will turn universal indicator solution from green to red. So common mistake is that students will just say turn red without saying that universal indicator green to red, right? Because the default color of universal indicator is green. So you have to say green to red. You cannot just say turn red, right? It's a common mistake. Another common mistake that students say is green to yellow and orange. This is not true. HCl is a strong acid, right? So it must be red. Yellow and orange is more for weak acid, right? So weak acid, you can think of anything with COOH. Anything with COOH confirm weak acid, confirm plus chalk. Okay? And then just a recap of the colors, right? Don't confuse red with orange, right? A strong acid is red, pH range 0 to 2, weak acid is 3 to 6, right? The weak base is 8 to 11, that's blue. Another one, blue and purple, students always confuse, always swap the other way around. Blue is for weak base. Purple is for strong base. Okay, so I provided some examples for you over here. Okay, so unfortunately, this with the time, okay, silicon dioxide is not a salt, right? So salt, right? Salt is an ionic compound. Okay, salt is not a covalent compound, right? Salt is an ionic compound. Salt contains cation and anion. Okay, so for example, your Na plus and your Cl minus. SiO2 is your giant covalent structure. Okay, and for some of the common species like carbon black solid and some of the just some common species that you need to know the color. You don't need to know the color for every single species. Okay, so for transition metals, most of them are colored. Then for the salts of your non-transition metals like your magnesium chloride, your potassium chloride, these are the sorts of non-transition metals. So most of them are white. Okay. So this is just a general guiding rule. Then for carbon, carbon is basically your black solid. Carbon, your graphite, right? The black solid. Okay. Okay, so unfortunately, I don't have the time to go through the rest of the questions in this session. These answers will be sent. I do have some slides that I need to go through first before I end this session. Now, for those who are thinking of doing chemistry in JC with the goals of pursuing JC, right? Please know that we know O levels is tough, right? I myself have sit through O levels. It's not easy, for sure. It's not easy. But the jump from O level to JC is quite huge, right? JC is another ballgame, right? And as you can see on these reviews over here, right, it has been a big struggle for many people, right? For those who are considering to take chemistry in JC, right, please take note. This is a huge jump from O-level pure chemistry, right? It requires a higher level thinking and application skills instead of just a factual knowledge where you just cut and paste, cut and paste. There are still questions where you are supposed to just define, state, and all that for 1 mark or 2 marks. But these form the minority of the questions in the exam. Majority requires higher level of thinking and application skills instead of merely stating the concepts. It's common for students to struggle even if they've done well for O-level chemistry. And having a solid foundation in JC1 can really make a difference. Okay, to both your content mastery as well as your confidence, right? So imagine if you don't do well for your first few months really, then it will really affect your confidence and your motivation to continue to study. And what's going to happen? You will accumulate your doubts and your misconceptions, and over time, it will just snowball into something that is pretty difficult to overcome, right? Understanding of content is not enough because with poor application skills and answering techniques, you may still not get your marks and you may even fail, right? This will affect your performance, your motivation, right? So if one subject is not doing well, it does affect your overall motivation level in your JC, right? Over time, your learning curve will become very, very steep, and your likelihood of scoring well will diminish significantly, right? Makes sense because as your doubts accumulate and as the time towards the exam gets shorter and shorter, it gets progressively difficult to climb back and overcome to get a good grade. Okay, but no worries, Overmark is here to help you. So as seen in these reviews over here, we have students who found our lessons very helpful in helping them in their content mastery and answering techniques in the exam, as well as their overall grades. Right? Early bird registration for JC1 classes is open already. So these are the list of perks. You can scan this QR code to sign up. The deadline for early bird will be 4 days later, 31st of October. So this Friday is the last day to sign up for our early bird, right? So I mean, after that you can still sign up, but just that there'll be no early bird perks lah. Okay, so for my JC2 sorry, not JC2. For my H2 chemistry JC1 classes, I'll be opening two classes. One will be Jurong East 7:30 to 9:30, and the other one at Bukit Timah 5:30 to 7:30. Okay, if you have more questions, you can reach out to me on my Instagram or Telegram, right? It can be whether you want to clarify your doubts for today's paper, or you want to ask more about your JC life, or choosing your post-secondary pathway in general. I can help with that as well. Okay, if you have any additional questions and you have more questions you'd like to ask, you can head over to our Telegram channel where, like I said, the answers will be uploaded. Right, we'll be opening some chats for you guys to ask tutors last minute questions, and you can download the 2024 paper that we just went through. Okay, do you find this session helpful? If yes, do leave us a Google review. We will appreciate very, very much. Right, scan here to leave your Google review. Right, and honestly, I enjoyed conducting this session as much as, and I hope you guys enjoyed, this lesson as much as I enjoyed conducting it. Okay, thank you all so much for your attention. Right, I will stop the recording here.